Start with a question. I've got a cool mug and a hot plate. And if I take the cool mug and put it on the hot plate, how will the temperatures of the two change? How will the temperature of the cool mug and the hot plate change if I put them together? We'll give you some choices. And in fact, this is something that you're familiar with from everyday experience. We can see the temperatures directly because we've got a thermal camera, and we can see the bright is hot and the dark is cool. And so we can see we have a hot plate and I have a cool mug, and if I put them together, what happens is this. The temperature of the cool mug begins to rise because heat is transferred from the hot object to the cool object. And this is something that you're familiar with. This is something that's part of your everyday experience. And we'll let this go for a while. Okay, now that the mug has sat there for a while, we can see the difference. Look at the mug. And it's a color-changing mug, so I can see visually that the temperature is warmer. But I can also see in the thermal camera, the mug is warmer. And you can't see it as well, but it turns out that the hot plate has actually gotten a little bit cooler. And we know what's happened. Heat has been transferred from the hot plate to the cold mug. And so the temperature of the mug went up, the temperature of the hot plate went down. Heat is transferred from hot objects to cold objects. And you know from everyday experience that that is the direction of the motion of heat. And heat, we're going to mean something very specific in this chapter, and it's the energy that's transferred in a thermal interaction. And so the thermal energy of the cup has increased, the thermal energy of the hot plate has decreased. Energy has been transferred. But energy is still conserved. Energy is still conserved. We just have to broaden our notion of the law of conservation of energy. Now, one way I can increase the temperature of something is by heat. Heat is transferred from one object to the other. The temperature goes up. The temperature of the mug increases. But another way I can increase temperature is by doing work. This fire piston right here has a plunger. When I rapidly depress the plunger, I'm going to do work on the gas inside the piston. And when I do work on that gas, I'm compressing it. I'm doing a force and a distance. I'm doing work. I'm going to increase the temperature. I'm going to increase the thermal energy of the gas inside the piston with dramatic results. There's a little bit of cotton inside there. And if I do this quickly, the temperature gets high enough that the cotton ignites. And so that was putting energy in, increasing the thermal energy by doing work. This was increasing the thermal energy by transfer of heat. And in Chapter 11, you're going to learn the first law of thermodynamics. And the first law of thermodynamics says that the change in thermal energy is equal to the sum of the energy input as work and the energy input as heat. But it's really just an extension of the law of conservation of energy that we've been talking about. There's also the second law of thermodynamics. And the second law of thermodynamics says that heat goes from hot objects to cold objects. And it always works that way. You know that. And so what the second law of thermodynamics does is it specifies a particular direction in time. And so things always go in a particular direction. Heat is transferred from hot objects to cold objects. But there's more to it than that. Once one form of energy turns into thermal energy, it's very hard to get it back. If I take a rubber ball that's bouncy and I drop it on a plate, I have potential energy, kinetic energy to elastic, potential energy back to kinetic. This process is largely reversible. So if I take a video of this motion and reverse it, it doesn't look wildly different. But if I take this ball and drop it, the energy turns into thermal energy. This ball warms up a little bit. And when that happens, it doesn't go back. So if I take this video of me dropping the not bouncy ball and play it backwards, this looks distinctly like something you've never seen before. It doesn't violate conservation of energy. It could be the plate was warm and it transfers energy into the ball, launches it into the air and into my hand. But in fact, you never see that happen. So heat flows from hot to cold, and there's certain actions that only go in one direction. And that's the essence of the second law of thermodynamics, which is something else you'll learn about in Chapter 11.